Almost all tunneling projects require shafts, either as start and reception shafts for the tunneling process or for inspection. Ventilation and rescue purposes. There is also a trend towards infrastructure installations at ever deeper depths, driven by, among other things, deep sewer construction projects that aim to avoid pumping stations as well as the need to build new installations below existing infrastructure. The vertical shaft sinking machine, VSM, was originally developed by Heron Necht for the mechanized construction of deep launch and reception shafts for microtunneling. After starting design and testing in early 2004, the first Heron Necht VSM equipment went into operation in Kuwait and Saudi Arabia in 2006. The machine concept, fully remote controlled from the surface, as well as its implementation on site, proved to be an efficient solution right from the start for the safe and fast realization of shafts, especially in difficult, inner-city environments, without lowering the groundwater table. The VSM technology masters the main challenges associated with shaft sinking. Inner-city shaft structures demand safe working conditions for surrounding buildings and the environment, especially potential ground settlement. There is an increased requirement to avoid the lowering of groundwater during the construction of shafts in order to avoid the associated settlement, which can affect a wide area. Deep shaft construction companies often encounter difficult geological conditions such as high groundwater pressure combined with layers of hard and soft material. In addition, deep shafts need special attention for the safety of the operating personnel. Simultaneous excavation and ring building facilitate high advance rates and shortened overall project duration. At the same time, continuous performance ensures overall high planning reliability for all stakeholders. The lining of a VSM shaft consists of either precast segments or cast in situ concrete. As the lining installation is completed on the surface, high-quality installation can be accomplished, leading to greater accuracy of the shaft structure. In most cases, a secondary, time-consuming lining is not required, resulting in a reduced wall thickness of the shaft and, thus, less soil excavation. As the water level in the shaft is maintained close to the groundwater level outside the shaft, water flow is prevented, which otherwise could cause ground movement and lead to a high risk of settlement. The Heron Necht VSM can be applied below groundwater with a hydrostatic pressure of up to 10 bar and in heterogeneous soil and hard rock of up to 140 megapascals compressive strength. All installations, including the lining erection, are remotely controlled from the surface. No personnel have to enter the shaft until it has reached the final depth and is fully secured. In general, mechanized shaft sinking requires less personnel and machinery on site, which leads to minimized risk exposure. Measures for groundwater lowering are not necessary, as the VSM machine concept is designed for operation under groundwater. As the VSM technology applies a high degree of accuracy of shaft construction, the shaft lining thickness can be reduced to a minimum, which reduces the amount of excavated soil. The VSM consists of two main components, the excavation unit and the lowering unit. The excavation unit systematically cuts and excavates the soil and consists of a cutting drum attached to a telescopic boom that allows excavation of a determined overcut. The lowering unit on the surface stabilizes the entire shaft construction against uncontrolled sinking by holding the total shaft weight with steel strands and hydraulic jacks. When one excavation cycle is completed, the complete lining can be lowered uniformly and precisely. A slurry discharge system removes the excavated soil, and a submerged slurry pump is located directly on the cutting drum casing. It transports the slurry to a separation plant on the surface. The whole operation is controlled by the operator from the control container on the surface, where all machine functions are remote controlled. Depending on the space conditions on site, the VSM components can be positioned flexibly to suit local circumstances. As most sites are located in heavily built-up urban areas, the access for logistics is limited. However, special concepts to relocate components such as the separation plant are available. After preparation of the site surface, a concrete ring foundation has to be installed in a pre-excavated pit. This foundation bears the loads of the VSM and serves as a support for the lowering units, which guide and hold the shaft at all times. The size of the ring foundation depends on the ground conditions and the size of the shaft. Connection bolts for various VSM components such as lowering units, recovery winches and energy winch tower are also integrated into the ring foundation. After pre-excavation and ring foundation, the installation of the cutting edge and the first segment rings are the next steps. The cutting edge is designed to cut the shaft profile in soft and loose soil conditions. Its design depends on the shaft diameter and wall thickness. It can be integrated as the first concrete segment ring or welded onto the shaft lining as a separate steel ring. The first 5 meters of the shaft lining constitutes the so-called start section, which has a stronger steel reinforcement to be able to take the loads and reaction forces of the machine during excavation and shaft sinking. Furthermore, the shaft lining is equipped with cast-in steel plates, onto which the brackets for the machine arms of the VSM are welded. As the VSM employs a sequential partial face excavation technique, there is no torque transmitted into the shaft structure. The excavation unit arrives on site in 3 parts: telescopic boom with the cutting drum, machine main body, and the adapter parts to the required shaft internal diameter. The lowering unit consists of the strand jacks and the coiled steel strands on our drum. The number of strands depends on the total predicted weight of the shaft, including the machine weight and the estimated buoyancy and friction forces. The strand jacks are bolted to the ring foundation by anchor bolts. Coming from the strand drum, the strands are fed through the strand jack, lowered through the outer annulus of the shaft wall and connected to the cutting edge. When all strand jacks are installed and connected to the cutting edge, the strands can be tensioned and carry the loads. Now, the pre-assembled excavation unit can be lifted into the start section. The VSM is secured by hydraulically activated locking bolts. When the VSM is in place, the recovery winches are installed and connected to the 3 arms of the machine. The recovery winches are used to recover the VSM for required maintenance or for final machine recovery. Next, the energy chain tower is installed and the excavation unit is connected to the hydraulic and electrical supply as well as to the feed and discharge lines. Before excavation starts, a calibration of the VSM in reference to the projected alignment of the shaft is required to ensure the accurate action of the cutting boom. Stored data, together with the position of the cutting boom, is shown on a graphic display, giving the operator full control of the excavation and sinking process. The excavation unit can be operated in 3 different overcut options, which requires the installation height measured from the level of the cutting edge to be adjustable. In its highest position, the excavation unit is not able to create an overcut under the cutting edge, which is important in soft or unstable soil to maintain surrounding stability. When an overcut is required, for example, in stable or cohesive soil, the excavation unit works in its lowest position. In this case, the annulus should be stabilized by a bentonite water suspension. In addition, each segment can be equipped with bentonite nozzles for lubrication, which can also later be used to grout the annulus. The standard installation is to connect the segments in ring number 3 and 5 with the bentonite mixing unit right from the beginning and to lubricate from these 2 segment rings at the shaft bottom during the sinking. The stabilization of the annulus together with the controlled sinking of the shaft by the strand jacks minimizes the risks of settlement. During the excavation and sinking process, the shaft is kept full of water to balance the level of the groundwater table in the surrounding geology. The cutting drum cuts and crushes the material to a granular size that can be handled by the pumps. Pump capacity, 200 to 400 cubic meters/h. A slurry circuit transports the excavated material from the shaft to a separation plant on the surface. The telescopic boom allows varying inner diameters between 5.5 and 18 meters with a reinforced frame structure. Excavation is possible even in water depths up to 85 meters. The cutting arm moves radially from the center to the outside of the shaft with an additional telescopic extension of 1 meter. With a rotation of +/190 degrees, the cutting boom covers the whole cross-section of the shaft. The cutting speed and the movement of the boom can be varied to achieve the best excavation rate. In most cases, The shaft lining consists of precast concrete segments installed at the surface. This so-called ring building is comparable to segmental lining in tunneling. The ring is built at the surface by crane. The number of segments depends on the shaft diameter. Ring building work includes the proper connection of the rings by anchors and bolts, which can be handled from outside the shaft. The excavation process of the VSM is not affected by the ring building process, increasing shaft sinking performance.
Alternatively, in-situ concrete casting of the shaft walls is another solution, especially for larger shaft diameters where segment handling becomes more difficult. In this case, the progress of shaft construction works is slowed down by the necessary time to build the formwork and the setting time of the concrete structure. The benefit of in-situ casing is the continuous structure without joints and the possibility to integrate entire entry and exit structures, e.g. for microtunneling activities in the shaft walls. After reaching the final depth, the bottom plug has to be installed. Usually, the VSM is used to excavate the required overcut. When this final excavation is done, the VSM can be disconnected, recovered by the recovery winches and lifted to the surface and out of the shaft by a crane. The bottom plug is cast with underwater concrete. The shaft annulus is then grouted through the lubrication lines to stabilize and anchor the shaft to the surrounding ground. Finally, the shaft water can be pumped out and the shaft is completed. Please do like and subscribe to my channel and press the bell icon to never miss new